In order to ensure the attack is successful, the most recent GPS ephemeris file needs to be used. You can obtain the most recent ephemeris file from NASA's FTP server in the BRDC directory for the current year. That FTP server is linked right here within the GitHub repository for the SDR-SIM project. So we'll go down and get that file. It's going to be all the way at the bottom within each of these directories. Alright, here's our most recent file, so we'll download that. Open it up. I'll just extract it right to my home directory. Okay. So there we go, that file is here. Now we'll copy that file into the directory where I've installed the GPS-SDR-SIM tool. And we'll go into the tool directory. Now we can use GPS-SDR-SIM to generate the file containing simulated GPS signals that will be sent to the SDR. We can do that here, so we'll run this tool. The -e option is used to pass in the signal file. We're going to give it a location, some coordinates that I obtained from Google Maps, and in a few minutes you will see where these coordinates actually are. And then I'm going to give it 100 meters as an altitude, because that's also a required parameter. We'll then give it a 1 megahertz sampling rate, because that's what works best with LimeSDR, and we'll also tell it to use 1 byte encoding for the file. Go ahead and run that. It takes about 30 seconds to generate this file, and when it's done, as you can see here, it will give us 300 seconds of simulated GPS signal data starting from midnight this morning. Just another moment, you can see it's very fast, so it'll reach 300 in another few seconds. Alright. Just about there, and wonderful. Okay. So that generates a file called GPS-SDR, or rather GPS-SIM.bin. So we'll go ahead and copy that file, which contains the simulated signal files, into the directory where the tool will use to pass it to the radio is. So let's go into that directory. And from here, we are just going to run the tool to send those GPS signals to the LimeSDR. So we're going to use the Lime Player utility, which comes with GPS-SDR-SIM. We're going to use that 1 megahertz sampling rate that we talked about. Again, 1 byte encoding. We're going to pass it a couple more options as per the instructions for this project, and we're going to feed it that binary file. So with that set, before I run this, if you look at my screen on the right, which is mirrored from my iPhone, you can see my current location is just down the street from RIT here in Rochester. So I will go ahead and run this command. Alright, it usually takes somewhere between 10 and 20 seconds, so let me switch here to a GPS app, testing app that will show. So those are my current coordinates in Rochester. I will go ahead and reset the GPS receiver, force it to search for GPS satellites. Sometimes it takes a couple tries for that to kick in. Just bear with it for another few seconds here. It's taken up to a minute before to pick up. We'll just keep letting it run for a moment here. Part of the challenge with this is that it's currently connected to Wi-Fi so that I can mirror my image, and it does pick up some location data from Wi-Fi. So we have to wait for it to actually pick up a GPS signal, which it will, if we bear with it for just a moment. There we go. Alright, so we've picked up a different set of coordinates, and you can see I have a wonderful GPS signal, which is very unusual for standing in the middle of a multi-story building on the bottom floor. So now if I go back to my Maps app there, and let's see what our current location is. There we go. Look at that. I'm in Moscow. And in fact, if you zoom in a little bit there, you can see I'm apparently just down the street from the Kremlin. So that's all there is to it here. You can also see that my phone has changed my time zone to be Moscow time because it does think I'm there now. And that is all there is to it.